Hello. In this collection of lessons, this chapter has been focusing on solving systems of equations. We started off with finding where two lines crossed. Prior lesson, we looked at finding where three planes cross. We had three equations and three unknowns. And in this section, it's kind of a collection of a variety of different types of equations. We'll have some circles, some ellipses, some parabolas, and we'll talk about applications to it as well. So it's going to test your algebra skills, but that's why they call it a college algebra class. So it's mostly just quite a few steps. You just have to be really organized and be able to follow basic properties of algebra. So here we go. We're going to start with a discussion about why we might look at solving systems like the following. And to start, I would ask you if anyone knows what the doomsday clock is, and I'm going to share with you what it is. You can look it up on Wikipedia. There's actually a really interesting Wikipedia page about it. But here's what the doomsday clock is. The doomsday clock is a symbol which represents the likelihood of a man-made global catastrophe. It's not going to be like a heartwarming topic. Maintained since 1947 by the members of the Bulletin of the Atomic Scientists Science and Security Board, the clock represents an analogy for the threat of global nuclear war. Why did they choose 1947 to start? Well, because the World War II had ended in 1945 with the bombings at Hiroshima and Nagasaki. So they invented the clock to kind of track how careful we need to be as a human species. Since 2007, it has also began to reflect climate change and new developments in the life sciences and technology that could inflict irrevocable harm to humanity. The clock represents the hypothetical global catastrophe as midnight. So if the clock ever hit midnight, that would be, the end of humankind as we know it. The Bulletin's opinion on how close the world is to a global catastrophe as a number of minutes to midnight. Its original setting in 1947 was 7 minutes to midnight. It has been set backward and forward 22 times since then. The smallest ever number of minutes to midnight was 2 in 1953. And the largest that we ever got to was in 1991 was 17. As of January 2017, the clock is now set at 2.5 minutes to midnight due to a, quote, rise of strident nationalism worldwide. United States President Donald Trump's comments over North Korea, Russia, and nuclear weapons. This setting is the clock's second closest approach to midnight since its introduction. So the doomsday clock is human caused. There's also a likewise thing known as the doomsday rock, which would be the fact that a noticeable asteroid strikes Earth on average once every 250,000 years. Because of this, it is important to be able to model paths of astronomical objects, which are obviously nonlinear. They will follow ellipses and parabolas and hyperbolas depending on the speed and the gravitational pull of the objects involved. So our tools for solving these are actually the same tools we've used. So we're really using very basic tools in pretty advanced settings. We're going to be using substitution and elimination. So example, a planet's orbit follows a path described by the following. If you don't know, we'll talk about in a later section, this actually makes an ellipse. A comet's path can follow a parabola. It comes close and then it gets shot back outward. And the path of that parabola could be modeled by y equals x squared minus 4. Under the model, what are the coordinates of intersection? When would the two cross? So the first equation, 16x squared plus 4y squared equals 64. The second equation, y equals x squared minus 4. The best method is going to be substitution because we already have y solved for. So we're going to be solving with substitution. We're going to take this y and we're going to substitute it into the y value in the first equation. So now that first equation is going to be, and this is going to be a little intensive. You're going to have to take some pretty meticulous notes. 16x squared plus 4 parenthesis x squared minus 4. I didn't mention the title of the lesson is Solving Systems of Nonlinear Equations. You should find that modeled in your note packet. It's equal to 64. I substituted this right here. This is the y value I substituted in, and it also needs to be squared. The first thing I should do then is to square this. I would multiply it out. So you would be doing x squared minus 4 times x squared minus 4. That's what you would be writing right here. 16x squared plus 4 equals 64. So you need to multiply that out. You could think about it as FOIL or multiple distribution if you'd like. But however you think about it, you'll end up getting x to the fourth minus 8x squared plus 16 when you multiply it all out. Now you distribute the 4 through. 16x squared plus 4 times x to the fourth. Then the 4 will distribute to the middle part. That'll make minus 32x squared. Then the 4 will distribute to the 16, and that makes 64. Now, you would combine any like terms that you see. Well, I've got 4x to the fourth. That's the biggest power. This 16x squared minus 32x squared, that'll make minus 16x squared. And then this 64 and that 64 are actually going to cancel each other. So then I'm left with that equals 0. How am I going to solve this? Well, I have a polynomial equal to 0. I'm probably going to look to see if I can factor. I'm going to do greatest common factor factoring. I divide out the biggest number that I can, which is a 4, and the most amount of x's, which is an x squared. Now in parentheses, I write what's left behind. This was originally a 4. I divided it out. This had 4 x's. I already divided 2 out. This has a negative 16. I divided 4 out, so it's minus 4. This had here. This is as factored as it can get, but this second one, actually, I can factor more. I could write this as x squared plus 0x minus 4. And then I would think to myself, hey, what two numbers multiply to make negative 4 and add up to be 0? That's a difference of squares. It's plus 2x and minus 2x. So I would get x plus 2, x minus 2. Now I have it all the way factored. I just go down the line and solve. What would make this one be 0? Well, if x equaled 2. What would make this one be 0? If x equaled negative 2. What would make this one be 0 if x equaled 0? Some people say negative 4, but you can try negative 4 squared and make positive 16 times 4 is not going to do the job. There are my 3 x values. How do I find the y values? I put them in to either of the original equations, but the second one I already had y solved for, so I just substitute in for x and then solve for y. Y equals x squared minus 4. If I put 0 in there, 0 squared minus 4 would be negative 4. So the first one is 0, negative 4. There's the first point where they would cross. Second one, y equals negative 2 squared minus 4. That's going to end up being 4 minus 4 would be 0. So negative 2, 0. Last one, y equals 2 squared minus 4. That again gives me 0. So I get positive 2, 0. And there are my 3 answers. 0, negative 4, negative 2, 0, positive 2, 0. If I zoom it all out, it looks like that. As I told you, there's quite a few steps. Each step's not too bad. What did it involve? Substitution, little double distribution, foiling, combining like terms. You did that in middle school. Some factoring from Algebra 1 and Algebra 2. And then once you had your x values, solving for y to get your 3 points. If you type the equations into Desmos and ask it to find where they cross by just looking at the picture, does it look like our answers check out? And they do. There they are. There's our 3 points of intersection. So there's our first one. I'm going to try another. Then I'll have you try. This one, again, this is an ellipse and a circle, asking where those two are going to cross. Which tool do you think would be best to solve this one, substitution or elimination? I hope you'd say elimination because you notice the y is already matched up and I can't really easily get x or y by itself without trying to take a square root. So I'm going to use elimination. Subtract to get rid of my y squareds. 4x squared minus 1, x squared would be 3x squareds. The y's are gone. 13 minus 10 is 3. If I divide by 3, I get x squared equals 1, and then I take a square root. And if I take a square root, you can't forget that you're going to get 2 answers. X equals plus or minus 1. Then you need to solve for your 2 answers. So x equals 1, x equals negative 1. If x equals a 1, if you put 1 in for x and solve, let's use the bottom equation, I would get 1 squared plus y squared equals 10. Subtract the 1 squared, which is 1. I get y squared equals 9. And then I take a square root to solve, and I get plus or minus 3. So actually this produced two more answers. So when x is 1, y could be a 3, or when x is 1, y could be a negative 3. So I get two answers out of that point. Over here, if I put negative 1 in for x, and I'm using the bottom equation, you could use the top, it would turn out you'd get the same value. Plus y squared equals 10. I end up getting, again, y squared equals 9. I take a square root. I get y equals plus or minus 3, which again means when x is negative 1, y can be a positive 3, or when x is negative 1, y could be a negative 3. And I get two more answers. So this one actually has four solutions. I'll show you why when you look at the picture, but my two answers are 1, 3, 1, negative 3, negative 1, positive 3, and negative 1, negative 3. If I show you a picture of the graph, you'll see there are 4 points of intersection. That is why you would get four answers. So there you go. One example of using substitution, one example of using elimination. Again, the tools that we're using are fairly simple. Substitution, elimination, it's just you really have to remember a lot of your algebra tools. I'm going to give you a chance to try. Find the points of intersection for the following systems. So pause the video now. I would probably give maybe 2.5 or 3 minutes in order to solve this one. Unpause it after that time's gone by. Everyone's had a chance to try. Feel free to ask each other questions or a guest teacher questions, or save it for when you can visit with me. And so let's pause the video now. Give yourself a chance to try. Unpause it once you've given it a chance. You want to see what the answer is. So pause video now, please. Okay, first thing you need to do is decide if you're going to do substitution or elimination. Either one's fine. I think it's already set up for substitution, so I would substitute there. You then get x minus parenthesis x squared plus 1 equals negative 1. You distribute, you get x minus x squared minus 1 equals negative 1. That'll leave you at negative x squared plus x. These will cancel out, equals 0. If you divide the negative 1 out with the x, so you're doing greatest common factoring again, you end up getting the following. And once you're there, you find your two answers are x equals 0, x equals, when I divide out the negative 1, I forgot, this should be a minus. There's your two x values. Once you have your two x values, you should be able to solve for y. So there you go. We got one last one to try, and that's finding where this parabola and the circle are going to intersect, and we're going to do this one by elimination. I see that it could be set up for substitution, but I just want to show you that you can do it honestly either way. So if I want to do this via substitution, elimination, I probably need to rewrite this top equation. So I'm going to rewrite this top equation so x and y are on the same side. So this bottom one's already set up. It's got x squared plus y squared equals 9. The top one, I need to subtract the x squared over to the other side, so it would get set up. So then I'd have minus x squared plus y equals 3. Then I'm going to add the two equations. Negative x squared plus x squared makes 0. Y plus y squared. These are not like terms. This is a single y. This is a y squared. So I would just write this as, you can write y plus y squared. I'm going to write the y squared first. Y squared plus y equals 3 plus 9 is going to make 12. Now I want to solve side equal to 0. So subtract y squared plus 1y minus 12 equals 0. Hey, it's set up to be factored. Two numbers that multiply to make negative 12 add up to be a 1 are going to be positive 4 and negative 3. Now my two answers are going to be when y is negative 4 and when y is positive 3. How do I find x then? I substitute it into either one of the original equations. It doesn't matter. Let's do the top one. Y equals x squared plus 3. Y equals x squared plus 3. If I put negative 4, let's do the 3 first. It's positive. Let's put 3 in for y. If I put 3 in for y, I would then get 3 equals x squared plus 3. Subtract the 3. I get x squared equals 0. Take a square root of both sides, and I get 0 equals x. So there's only one answer here, 0, 3. If I try the other one, put -4 in for y. -4 equals x squared plus 3. Subtract the 3, I get -7. And if I take a square root here, I'm going to get imaginary answers. So this is non-real. So there's only one solution. It's going to be the 0, 3, because I can't take square roots of negatives without involving imaginary numbers, which will not show up on my xy graph. So 0, 3 is my only answer. If I zoom it out so you can see all the steps, there they are. I'll show you the picture of what the solution system looks like. Does our answer check out? It does. You'll notice the -4 return an imaginary answer for x, and therefore is not an intersection point. This parabola and that circle are only crossing at one point, the 0, 3. I think I'll just leave it at that. Actually, no, we'll give it a try. Last one, solve by your method of choice. You have x cubed, x squared. You have a plus y minus y equals 0. This should actually go fairly quick. So pause video now. Maybe give 2 minutes for people to try it. Decide if you're going to solve by substitution or elimination. You can use either one, but one will be much quicker than the other. Pause the video now for 2 minutes. Unpause it when you want to see what the solution is. Okay, this should have been done probably by elimination. You're going to want to add the two equations. Your y's will cancel out, so then you'll get x cubed plus x squared equals 0. Then you'd do greatest common factor factoring. You can't divide out any numbers, but you could divide out x squared, so you get x squared. What would be left behind? An x plus a 1 equals 0. Your two values then would be when x is 0, when x is a -1, and when x is 0, you end up getting y is equal to 0. When x is -1, you get y is equal to +1. So there are your two answers. The graph for this is a cubic, this is a quadratic, and so it looks like that. And there's your two solutions. Now you should be well prepared. You've seen examples of anything that could come your way. Just have to be steps yourself. So thank you very much and have a good day.